Good morning. Today in geometry, we're going to start chapter 4. So we're going to start with lesson 4-1 that talks about classifying triangles. And actually, chapter 4 is all about triangles. So you're going to learn probably more than you ever wanted to about triangles. We're also going to get into some triangle proofs later on in the chapter, not right away, but about like the second half of the chapter, we're going to get into proofs again as well. Okay, so there are two different ways to classify triangles. The first is by the angles. The second way is by the sides. Okay? So let's first look at classifying triangles by their angles. The first triangle, according to its angles anyway, is an acute triangle. And that just means that all three angles are acute, which means less than 90. Okay? So maybe an acute triangle would look something like that. So all of these angles are less than 90 degrees. Okay? The next next triangle, according to its angles, is an obtuse triangle. Okay? And an obtuse triangle means that one angle is obtuse, meaning greater than 90. Okay? So if one of the angles is obtuse, that would mean that the other angles would have to be acute. So like this one right here that I put the little dot in, that one would be the obtuse angle. Okay? The next one, according to the angles, is a right triangle. And I think you all know what this one is. This one means that one angle equals 90 degrees. Okay, and then that would follow that the other two angles are acute. Okay, so right triangle, I know you guys have seen a lot of right triangles, would look something like that with a little box in the corner. Okay, the last one, there's a fourth one, according to angles anyway. The last one we don't use as often. I mean, we're working a little bit, but that is what we refer to as equiangular, an equiangular triangle. Okay, so it's kind of right in the name. Equiangular means that all the angles are the same. Okay, so if all angles are the same, then it would follow that all angles measure 60 degrees. Okay, so 60 degrees would be the measure of each angle in an equiangular triangle. So equiangular is actually another type of acute triangle. It's just kind of more specific. Okay, so that's classifying triangles by their angles. Let's classify by the sides. There are three of them. The first one is scalene. Okay, a scalene triangle. That means that no sides are congruent. Okay, so all three sides are going to be different. All right, so maybe one that looks like that. Okay, all three sides are congruent. So I mean, and it could be a right triangle, it could be obtuse, you know, but scalene just means that all three sides are different. All right, the next one is isosceles. And an isosceles triangle means that at least two sides are congruent. Okay, at least two sides are congruent. So isosceles maybe looks something like this. So I'll mark the two congruent sides. Okay. The third and final way of classifying a triangle by its sides is equilateral. You guys probably remember this one too. Okay, equilateral means that all sides are congruent. Okay, so actually equilateral and equiangular are going to go together. All right, because if all the sides are congruent, all the angles are congruent, then we have it. All right, so for these, you're going to have to really watch for those congruence marks to tell, like what type of triangle you're dealing with here. All right. All right, let me show you a couple of examples. I actually have 3 total examples. Here is the first one. This one says, identify the indicated triangles in the figure, which I will draw in a minute, if UV equals VX equals UX. And here is the picture. Okay, and then I have VY, U, this is T, this is Z, this is X, and this is W. Okay, so the first kind of triangles, that we want to identify are the isosceles triangles. Okay, now remember, isosceles means that at least two sides are congruent. So technically, equilateral triangles are also considered isosceles. All right, so let's mark what we're given here. We were given that UV right here, this first red one, and VX right here, this one, and UX right here are equal. Okay, so it looks like we have an isosceles triangle that's also an equilateral triangle, don't we? For when you name a triangle, just make a little triangle symbol, and you're going to use all 3 letters just going in order. So U, V, X, or if you wanted to call it VXU or XUV, something like that. Okay? And honestly, just looking at what we have here, that looks to be the only one. Now, can we assume? No. All right? Maybe something looks like it might be isosceles, but we don't know for sure. Okay? How about the scalene triangles? Okay, so scalene means that none of the sides are equal. Well, looking at what we have here, since we can't assume, it looks like we have a lot of triangles. Okay, the first one that I'll put on here is VWX. That one could be scalene. Maybe another one is triangle UTX. Maybe another one is triangle YTU, and maybe another one is triangle ZTX. Okay, I think I got them all. So there are actually 4 scalene triangles in this figure. All right, good deal. Second example. In this one, we want to find D and the measure of each side of equilateral triangle triangle KLM if KL equals D plus 2, LM equals 12 minus D, and KM equals 4D minus 13. Okay, so we're told that this triangle KLM, is equilateral. Okay, maybe you don't need to draw a picture. Maybe you do. All right, so let's say that this is KLM. If it's equilateral, we know that that's true, that all three sides are the same. Okay, so KL is D plus 2, LM is 12 minus D, and KM is 4D minus 13. Okay, now because this is equilateral, technically we should be able to set any two of these equal to each other to find D. Okay, so let's go ahead and just pick, I don't know, I'm just going to pick two of them. Let's just pick D plus 2 equals 12 minus D. Those are the first two that we were given. Why not? Okay, so if we start by adding this D over, we now have 2D plus 2 equals 12. Subtract 2. Looks like 2D equals 10. Divide. Looks like D equals 5. We got the first part of our answer. It said to find D and the angles, or I'm sorry, the sides. Okay, well, if we plug in 5 plus 2, oh, that's 7. Shouldn't all of them be 7? 12 minus 5, yeah, that one's 7. This one should also be. 4 times 5 is 20. 20 minus 13, what do you know? It's 7. Okay, so make sure that you're answering all parts of the questions that you're given. All right, the last one. I told you that distance formula was going to follow you throughout this entire book. Here we go. Find the measures of the sides of triangle RST if R is -1, -3, S is 4, 4, and T is 8, -1. Then we are going to classify the triangle by its sides. Okay. So maybe to figure out what sides we're talking about, maybe it would help. I have no idea what kind of triangle this is. I don't know until I figure out these lengths here. Okay, so it looks like I have a side RS, and I have a side ST, and I have a side RT. Okay, so those are the three sides that I need to find. We're going to use the distance formula to do so. Okay, so let's go ahead and start plugging away. RS, so we have 4 turns into a +1 squared. 4 turns into a +3 squared. So that is 5 squared plus 7 squared. So 25 plus 49. So it looks like it is going to be the square root of 74. Okay. How about ST? 8 minus 4 squared plus -1 minus 4 squared. Okay, so we get 4 squared plus -5 squared. So that would be 16 plus 25. So that would be the same thing as the square root of 41. Okay, well, we don't have an equilateral triangle. Let's see if we have isosceles or scalene. RT, 8 turns into a +1 squared, plus -1 turns into a +3 squared. Okay, so we have 9 squared plus 2 squared. So it looks like we have 81 plus 4. So